Okay, so um, IoT is defined as a network of physical objects, or we call it as things that are embedded with sensors, softwares, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. Right? So that is a definition of IoT. So basically, what it says is that IoT is a network of devices that have the ability to take measurements about its environment and connect to a local server or a cloud and transfer information from the sensors to the cloud. So basically, IoT network must have the sensibility at the sensors. The sensors must be able to sense some parameter, right? It could be temperature, it could be pressure, could be light, right? It could be heat. So it should be able to sense something. And the second thing is that the device with the sensor must be able to communicate with another device which has a connection to the internet, right? So the basic need for IoT systems is having the ability to make measurements at the sensor level and transmit data or communicate data from the sensor level to the server level, or to the server which is connected to the internet, right? So the network connectivity and sensibility are two important requirements to form an IoT network. So they should be there in an IoT network for it to be called as an IoT network. So basically, an IoT network must have something called a thing or a device, right? Yeah, so the router is an access point, and so the gateway is a point which can process things. So router is a access point. However, we can do some computations at the router, but we connect that router to the some central server, to a local server which is connected to the internet, right? So a router is a intermediate node which we uh, can call as a gateway to the cloud. So yes, we can call a gateway router as a gateway, but the local server is the place where we connect to the internet. So having a router only is not the gateway. We have to have a local server as well, apart from the router, to call it the gateway to the cloud. So we call the local server as the gateway. So the the device will connect to the local server through a router. So from the local server, it will connect to the internet. So the local server is the point where which has the connection to the internet. So that connection will be maintained through maybe fiber network, or yeah, it could be some it can have wired or wireless connection with the cloud, that means the internet. So the at the local server, we need to we need to have fixed connection with the internet, right? So the gateway must have fixed connection with the internet. So that is the place where we call the gateway. So the device will connect to the gateway through wireless medium or wired medium. So if it is connecting to the local server through wireless medium, it could be through a router. So if the router is not doing the computation, it is not considered as a gateway. However, the next component, which is the server, which is collecting the data, is known as the gateway, which connects to the cloud and upload the data to the cloud. And then the cloud will contain the data and manage the data, and it will be as collecting the data over time. And there are tools that are available in the IoT cloud which can do analysis of the data that is collected. So the analysis of the data will enable us to take decisions about the data that we have collected and make some useful results out of the data that is collected. So the data that we have collected can have information. However, we need to use tools like machine learning to get some good results out of the information that we have collected. So, for example, we need predictive systems. We need to forecast different incidents in the future. So for such kind of instances, we need to use tools like machine learning. So in that case, we do such analysis of the data, and then we give the useful data to the user device or the customer through a certain user interface. So for the user interface, we are using softwares and some mobile applications or websites, and we give a visualization of the data that we have collected to the customer. So an IoT system will basically consist of things or devices, a gateway through which it will connect to the cloud, and and some analysis of data will be done after collecting the data in the cloud. And then the analysis output will be given to the user through the user interface. So the goal of an IoT network is to create a more connected and efficient world by automating the processes and improving the decision making based on the real-time data. So the IoT systems are expected to automate devices and the devices at the edge of a network and collect data at the edge of the network and use the data that is collected at the cloud to make important decisions. So as you think, do you need IoT in your day-to-day life? So do you think that we need to automate devices at the automated devices which can be connected to the internet, or do you think that IoT is a necessity in these modern days? So there are many countries who are already using IoT for different applications. So not only for the industries or for commercial activities, those countries are using IoT for many activities at homes as well. So they are going to use IoT for making their lives easier and to save time. So in that context, IoT is becoming more popular with the uh, uh, people, because it makes the life easier for doing different tasks. So I said before that one of the goals of this course is to prepare IoT system specifications for different user requirements. So based on the system specifications that have been given by some users, we need to design an IoT system. And in order to design an IoT system, we need to have several components in our IoT specifications. So we need to specify the user experience, how the user will experience the output of the IoT system. So how the output will be shown to the customer, right? So the customer, if for example, if we take a situation where we have a smart agriculture condition scenario, and the customer is a farmer. So the customer wants to know like what is the condition of the paddy field from a remote location. So the farmer does not want to visit the paddy field, but he wants to know what is happening with the paddy field in terms of different parameters. So based on the parameters that have been determined by the farmer, the IoT designer must design the output for the farmer. So if the farmer wants some details, they need to decide it and create the design of the user interface. And next, the IoT designer should design the architecture of the IoT network. So starting from the sensor level up to the database level, and up to the user interface level, the IoT platform must be designed and determined um, by the IoT designer. So the IoT designer must decide, okay, what type of sensors to use, what type of communication technologies uh, that we can use to communicate with the base station or the access point, and from the access point, what is the uh, place where it will connect to. Is it the core network, or how it will connect, and what is the server used, and then from there how the data will be collected and how the data will be managed, and then from there how the analysis of the data will be done, and the output will be delivered to the customer. Apart from that, we also need to manage the security of the data. So the security of the data is very important in IoT systems. So it is one of the biggest challenges currently in IoT systems. So the reason is that in IoT networks, we have multiple sensors and devices connected to the IoT network at once. So IoT networks are scalable networks to which multiple number of sensors can connect, and those sensors can send data at a single time, uh, and they can send multiple large amounts of data. So in that case, once such massive number of devices are connected to an IoT platform, it is difficult to maintain the security of the data if you don't follow a certain secure procedure. Otherwise, any device can connect to your IoT network and send their data to your IoT network, or else they can also access the data of your IoT system and maybe erase or damage or change the data that you have collected. So this data could be something very personal to you at certain applications. So if we are talking about health applications, the patients might not want their condition to be known by other people. So in that case, we need to encrypt the data with a suitable mechanism such that our encryption method and the keys that we are sharing are not known to the public. So in that case, we need to ensure the security of the data that we are transferring to the IoT network. So we need to consider security as one of the important parameters of the performance of an IoT network. So currently, it is one of the main challenges of IoT networks. And next, the quality assurance. So we need to make sure that the quality of the output that we are providing to the customer is up to the standard. So we might be able to give some data or output to the farmer, but the accuracy of the data must be in high standard. So for the accuracy to be in that level, we need to use like the most suitable sensors at the sensor level with less error. We would say like the less error tolerance and high sensitivity. And then the technologies that we are using to collect information and using to collect and store the information must be clearly um, done. And then, I mean, it should be up to the standard, and then the quality must be maintained. Next, the tools that we use to analyze the data must be able to really accurately forecast some output with a uh, higher accuracy. So if we are using, for example, techniques like machine learning to forecast the output, the accuracy must be above a certain percentage in order for the output to be considered reliable. So those aspects are considered when we are designing certain IoT system specifications based on a user requirement. Next, if we are going to design an IoT system based on a given set of system specifications, we need to consider the request of the customer, and we need to create the architecture of the system based on the different sensors and microcontrollers, and then communication technologies that are specified by the customer. So the customer might say they want to communicate the measurements from a distance range of 8 to 10 kilometers and so on. So if that is the case, we need to use the communication technology which can adhere to that requirement. So in that case, we have different technologies that we can use, but in that case, we need to consider like what is the best communication technology that can communicate up to that range, but also we need to consider the other factors, the power consumption, the data rate, and so on. So in that case, we need to select the best communication technology for connecting our sensors to the gateway. And then we have next uh, uh, the cloud, like how we can design the cloud and how we can manage the data and the databases in the cloud and so on. So once we have the um, uh, data in the cloud, we can manage the data and we can do the processing of the data, and we can give the necessary output to the customer. Next, if we want to design an IoT network, there are certain set of skills that we need to possess. So one of the basic skills that you need to have is programming skills. So the programming must be uh, must be uh, uh, applied in this microcontroller level, and in the cloud level, in the server level, in machine learning, in the user interface, and so on. So in every part of the IoT network, programming is used to develop systems, softwares, and applications that are required to get the output from that component. So because of that, programming knowledge must be improved in order to be a good IoT designer. Next, we need to do some research on latest trends in IoT to build an IoT network. So once we are selecting hardware that is required for the IoT network, we need to select the most latest and most reliable uh, processing boards and equipments and tools and softwares, so that we can get the maximum output of the IoT system. Next, we can also conduct research about the current IoT projects and IoT research works that have been done, and implement the optimal research or optimal IoT system for our requirement. And then we also need to have some experience with the existing IoT platforms in order to adhere to the customer requirements that are coming in the future. And then we also need to design our user interfaces and give our user a good experience by our user interface design. So these fields are all are very popular fields in the future, uh, even currently. So these uh, these are skills that will benefit anybody who is going to join the industry in terms of maybe software development, in terms of user experience, machine learning, cloud computing, and so on. So embedded systems and so on. So the all these fields are very trending fields as of now. So user experience is also like having a very a high demand for jobs these days, and therefore like being good in all these areas can enable you to go to a career which is very demanding during these days. So the popular platforms, IoT platforms that are there in the world are Amazon Web Services based cloud platform, Google Cloud Platform, Azure Microsoft platform, Cisco IoT platforms. So there are other IoT platforms as well. So these platforms are basically from companies which are known all over the world. So so I guess these are I mean these platforms are used by many people in the world. So it is better for us to get to know about the architecture of these IoT platforms. So I expect to discuss about these cloud platforms in the upcoming lessons of this module. So we have a different topic allocated separately for the cloud platforms and how they function and so on. So we'll discuss about that in that topic. So for an IoT platform to be successful, it should have key elements. So the IoT platform must support uh, low complex protocols. That means that IoT platform must not be having complex protocols. That means that once you have complexity included in the IoT platform, it is difficult for the system to address the lot of data exchange and the data requests coming from the connected devices. Therefore, it is because we are talking about collecting data over a small amount of time for a, within small amount of time for a long time. That means we are collecting data frequently over a very long time. So, because of that, we are transmitting high data rates from the sensor level to the server level. So because of that, we have high network traffic, and in order for us to have reduced congestion in the network, and in order to increase the efficiency of the data transfer, reduce the latency, we need to use low less complex protocols at the IoT platform. And such kind of protocols have been proposed for IoT platform. So we will discuss about the protocols in the upcoming lecture. So basically, we need to have less complex protocols for the IoT platform. And next, the IoT platform must be scalable. That means it must be able to connect to a massive number of devices. So our IoT platform must be designed such that it can adhere to the requirements of multiple devices. So it cannot just serve one or two devices. It needs to be able to serve massive number of devices, and therefore our design must be such that multiple devices can be, or additional devices can be added to the system and scaled. Next we have security. As I said before, we need to secure our data. So different standards and procedures and protocols must be followed by the IoT system in order to secure the communication. Next, we need to have analytic tools and visualization tools at the cloud level to manage the data, visualize the data, and then send the output to a certain software. Then software development kits, SDKs must be available, and tools related to software design must be available in order for us to give a visual output to the customer. So there are different advantages of IoT. So I think you already know about IoT a little bit. So IoT has been popular in the world for many years. So because of that, I think IoT is not a new concept. So IoT has been used for multiple applications. So basically, IoT is used for automation tasks, where we want to automate different tasks, and then we want to give a good user experience to the customers, and we want to give information to the customers regarding the environment. So depending on the application and the requirement of the customer, we are giving different outputs about the environment to the customer. Then we have innovation. So we have to in IoT we have a lot of innovation. So that means we are building new things apart from the existing available communication schemes and IoT systems. So innovation is always possible for IoT, because still many devices are still not connected to the internet. So in the future, the aim is to connect almost every object in our environment to the internet. And next, we have the connectivity. So Internet of Things enables us to have the connection with the other objects and get information from the objects. So this is something that enables us to access information even from a remote location. So a person who's not at the location of the workplace can remotely monitor the condition of the workplace using IoT. And then cost reduction. So rather than using other methods or other machines or even human labor to do the measurement collection or the sensor measurement collection, it is easy for us to use sensors at the network, IoT network, and then collect measurements from the places at the edge of the device. So these kind of applications enable us to even get information about critical places, such as like underground places where humans are not able to reach. So we can set up sensors at such kind of locations to monitor them regularly and get an update about such kind of places. So the places where humans cannot easily reach, we can install sensors in those places and get information regularly using IoT networks. So IoT device is a device that can connect to the internet, right? So we have smartphones in our hands. So our smartphone has many sensors installed in it, and it can make many measurements regarding its position, for example. So our smartphones have GPS sensors, right? The GPS sensor can collect information or receive signals from the satellites, and then using the satellite signals, it can estimate its own location, right? So therefore, it is a IoT device which can collect information from the environment and compute uh, at the uh, at the and upload its data to the internet and get an accurate position estimate at the phone. So even without a connection to the internet, you can get some estimation about your location from the phone. However, that is something that is done locally by the phone. So at the local levels, our phone is able to make an estimation about its own location. However, once that data about the location of the phone is uploaded to the internet can give a better accuracy of your location by changing all the conditions of the environment. So once we have Google Maps, for example, our location accuracy increases once we connect to the internet and we get information from the internet also about our location. So our accuracy increases once we connect our phone to the internet. Uh, However, even without the internet connection, we can make conclusions at the uh, edge level or the device level because the device is able to do some computation at the device level as well. So the phone is considered as an IoT device. The reason is it is having sensors such as accelerometers, GPS, Bluetooth, and so on. It can collect data and connect to other devices and transmits it data to the other devices and servers. The traditional phone, which does not have connection to the IoT, the internet, cannot be considered as an IoT device. So there are several standard organizations that define the standard for the IoT networks. So the IoT networks cannot be developed by different industries in different manners, right? They need to follow the standards that are defined by the standard organizations in the world. So there are different organizations such as IEEE, ITU, ETSI, IETF, and so on. So these organization give us the standards in what manner the IoT platform must be set up. So by doing that, the organizations or the industries, the universities are able to develop and propose new IoT systems that follow these standards such that they are feasible to be implemented anywhere in the world. And once even different companies, even if they are building different IoT projects or applications, they can be integrated together because of the standards that have been defined by these organizations. So next, I would like to speak about the history of IoT systems. So once we take into consideration the first IoT device that have been implemented in the world, it had been a Coca-Cola machine, which had been connected to the internet and there had been some sensors at the machine to collect some information about the temperature of the product and also about the availability of the product. So the people or the students, the customers who wanted to know about this data had connected their devices to the database that have the information regarding these machines. Regarding the data that is collected from this machine. So the world's first IoT device that had been implemented has been this Coca-Cola machine. So this has been the initiation for the IoT. However, there is a person known as Kevin Ashton, who is an innovator and a consumer sensor expert, who introduced the term Internet of Things to describe network connecting objects in the physical world to the internet. So he explained that the term Internet of Things, and he was able to define that the Internet of Things is something that is defined by the connectivity of devices to the internet and the ability for the device to make measurements. So he has worked he has coined this term in 1999. He has introduced an IoT network for different for different applications. So he has introduced an IoT network for supply chain in the US. So then he has also, he has introduced the IoT concept for a supermarket in US. And next, we have smart city concept in Switzerland and other countries. So this concept has also been developed based on IoT systems and collecting data and uploading the data in the cloud. And then we have the mobile device. So our mobile device is containing multiple sensors such as Bluetooth, RFID, near field communication, Wi-Fi, GPS, and so on. So all these communication enable our phone to work as an IoT device and easily obtain information and transfer information um, in different applications and get things done very easily and with less delay. So in the upcoming future, we are expected to have a connected everything networks. So that means that we are expected to have networks where we have all components in the world. Like if we take buildings, the buildings will be made with including sensors in the walls and so on. So once we have such kind of ability to monitor almost every like space using sensors, then we call it Internet of Everything. That means everything or every place in the world can be monitored using an IoT network and using IoT. So once that is possible, we are able to gain information about the environment with much efficiency and gain idea about what is happening in the future. And based on that, decisions can be made to do tasks that will give benefits to our lives. And then we also have, as IoT trends, we have machine-to-machine communications. So in that, direct device-to-device communication will be done. So direct device-to-device communication can already be done using technologies such as Bluetooth, Wi-Fi, and so on. So direct Wi-Fi and Bluetooth connectivity allow us to share information with other devices in the short range. However, once we consider about long range, right? So if we want to connect device to device directly, in a long range, we need other technologies such as cellular technologies. And these cellular technologies have introduced like technologies like side link communication to enable direct communication between devices. That means that telecommunication standards have been set uh, by the standard company organizations to enable direct communication between devices, right? So Wi-Fi and Bluetooth are two of the communication technologies, but since they are short range, we the industries want to expand the communication range to more than just 100 meters or 10 meters, something like that. So they want to expand it more than that, and therefore, like in the upcoming future, we will have direct device to device communications without the need of a network infrastructure. So that is what what we call as the M2M technology. Then we have Internet of Nano Things. So nano things will have communication between nano size devices with the internet. So nano scale devices will be having the ability to sense things in the environment, sense measurements, take measurements in the environment, and then upload its data to the internet. So we will have like nano items installed in places like buildings, in the material inside the buildings, and even in other industries where we need to monitor every single place in that building, for example, or that space. And we also have different wearable IoT devices that are upcoming and trending, such as watches, fitness trackers, and so on. So these wearable IoT devices are going to, it is said that they are going to replace the mobile phone usage in the future. So in the upcoming future, we will be using wearable devices and use that to connect to the internet, and we might not be using our mobile phones regularly. So that is one of the trends that are forecasted for the future. And then also we have another concept called digital twins. So digital twins is a concept where we are creating an environment in our own space about uh, an environment which is far away, which is in a remote location, and which is an area where we cannot access regularly. So once we have such a situation, we can, using software, we can visually create a virtual environment near our workplace, and use it to make measurements and make conclusions about the actual environment, right? For example, if we have some submarine or some ship that we have positioned in the sea, sometimes it is difficult for us to visit the sea, the location all the time. So in that case, we have this digital twin concept to make our lives easier, and just estimate the condition in the sea and the our equipments in the sea, and replicate the same environmental conditions in our workplace area. And then based on that, we can design and develop um, the system, uh, and design it according to our requirements using just the virtual environment that we have. So developing virtual environments is basically called digital twins. And then we have cloud computing as one of the trending topics. And cloud computing will enable us to gather data in the cloud rather than storing them in local devices. So the cloud will do most of the processing, and the computation at the edge level or the devices will be reduced. So in the future of IoT, such kind of changes are estimated to happen. And another IoT concept that is proposed by universities is a super IoT. So in super IoT, we have a sustainable Internet of Things. So that means that sustainable Internet of Things. So that means like we have an IoT system that is sustained. That means that the power supply that is required by the IoT network is provided or created by the IoT devices itself. That means that the IoT devices can use radio and light communications to do, I mean, the normal task of communication, but additionally, they can energy harvest, right? They can harvest the energy. So they are having the ability to uh, incorporate or optimize the energy that is received through the radio communications and the light communications, and use that energy at the sensor level to do the small energy consuming tasks. And that this energy harvesting, if improved correctly, can even supply energy enough for all the processing at the sensor level. So if that is the case, power supply at the sensor level will be reduced drastically. And in that case, once we are designing like say, IoT networks, we don't have to worry a lot about the power consumption at the sensor level. So because of that, the super IoT or the sustainable IoT networks are a good solution for power hungry computations and IoT networks. So, so one of the drawbacks of current IoT networks could be the power requirement at the sensor level. So actually we are using less complex computations and less power hungry sensors at the IoT networks. However, even they require some power, and such power sometimes cannot be supplied like at each sensor location. So in that case, we need to have a way of supplying power at the sensor level using other mechanisms like energy harvesting and so on. So that is one of the trending topics in IoT. And for mission critical IoT applications, we have different different requirements. So the mission critical IoT networks are requiring low latency, high reliability. That means that the data must be sent with high rate, and then the accuracy of the data must be high as well. So what I mean is like mission critical applications are used for cases where we have uh, applications like medical operations done in a remote location. Right? So once we have a human living person who is like having a surgery done, we need the data rate to be very high, such that the doctor is able to do real time operation with high accuracy, right? So if that is not met, then it is going to be difficult for the output to be okay, right? So therefore, for mission critical applications, IoT networks must be ultra reliable and low latency systems. So so in IoT, so basically there are some characteristics that IoT systems must maintain. So IoT systems must have connectivity. So they should have the ability to connect um, to different devices. So different devices must be able to connect to the IoT network, and they should be able to connect to the internet from anywhere and anytime. And then they also need to have a unique identity. So a unique identity can be supplied using an IP address and so on. So each device will have its own unique address. And then the IoT network must be scalable. So we must be able to connect multiple devices and increase the size of the network. Then we also need to incorporate security of the system. So as I said before, we need to secure our data by using different encryption, decryption methods. And then we need to like share the necessary keys and uh, private and public keys to maintain the security of the data. And then we have to have data storage systems and management and analysis systems to maintain the data and give the correct output. So there are different like devices which are popular in the world, right, for IoT. So as you think, what are the like popular IoT devices which are like used currently in the world? So there are some devices, right? So we have um, we have them already in the world. So in in houses also we can use different applications. So as you think, like what are some of the most popular IoT devices in the world? Right, so we have Alexa, right? That is one example, which is a product by Amazon, and it is activated by voice. And once we give some command to the IoT device can the Alexa can make a decision based on the information that it collects from the data that it gains from the cloud computing access. So based on the knowledge that it can gain from the internet, it gives the necessary output to the customer. So the customer can request for different items, and they can get information from this device. And similarly, the Apple company has implemented this Siri voice activated intelligent assistant that can give us information about, uh, I mean, any anything that we request from that assistant. So they are developed in such a way that the voice activated devices are really intelligent. The next thing I want to discuss is about the wireless technologies for wearable IoTs. So different wearable IoT devices can be used, and based on the requirement of the communication, we need to decide which type of communication technology is used for the different application. So different devices are there, such as fitness devices, glucose meters, watches, glasses, and so on. So these devices can be connected to the internet using using different technologies such as Bluetooth, Wi-Fi, cellular networks, and other communications such as Zigbee, near field communications, RFID, and so on. Right. So depending on the application, the type of communication that we choose must be considered. Right. So there are like different technologies that give different outputs. I mean, different performances. So depending on the performance that we require, we need to select the communication technology, right? If we want high data rates and high range or long range, we need to select the technology related to that, right? Also, we need to consider like what is the power consumption of the communication technology, right? When considering all these three criterias, we need to select the IoT communication technology. So it could be like difficult depending on the application, right? So if we are designing some application with low power, high range, high data rate, then we need to like select the corresponding technology, right? So I mean, the technology we select, even though we select it, sometimes it might have some disadvantages, right? So for one communication technology, we can have Bluetooth low energy technology. So in there, we can have high data rates with low power. However, we have short range communication with Bluetooth low energy, right? So Bluetooth low energy is not the same as Bluetooth. It is a version of Bluetooth which uses lesser power than the normal Bluetooth. So in that case, we have a low power consumption and a high data rate. However, we don't have high, communication range. Therefore, this Bluetooth low energy communications can be used in situations where we have the devices very close to the internet connection and the router, the access point. So we need when we connect our devices, we need to think about the range of the communication. So we can select Bluetooth for short range communications with low power and high data rate. However, if we want long range communications, we need to select something like cellular communication, LoRa communication, and so on. So LoRa communication, we can go for up to 8 to 15 kilometers and so on. So we can use LoRa communication for long range, high data rate, and low power communication. So we need to check all those things in the manuals, and then we need to select the correct communication technology. So LoRa, when we take into consideration, we can do long range communication using LoRa. So when we consider the cellular network communication, it also brings the long range communication, but it has a high power consumption. So in that case, it has some disadvantage. So because of that, we can consider high power consumption in cellular networks as a disadvantage. So high data rates are possible, but high power consumption is a disadvantage of the cellular networks. When we take into consideration Wi-Fi, there are also high power consumption is there, and however, high data rates are provided along a short range. So Wi-Fi is very popular when we want to have high data rates, and when we have short range communications to be done. However, the high power consumption makes it not suitable for applications where we are doing some remote monitoring, for example. So once we are doing remote monitoring, then we need to place our sensors in a remote location where we need to give power supply to the sensors. So it is difficult for us to give power supply to the devices when it is remotely located. So in that case, we need to have low power consuming communication technologies for our system. So we need to go for other types of communication technologies such as Zigbee, LoRa, near field communication, RFID, and so on. So these communication technologies must be correctly chosen and considered when we are designing an IoT network. So as the first assignment, I have given the regular students to get popular IoT products and get an image of it with its components. Right, get an image of a IoT product with its components. Right, take an image with which has components in it, which you can see the interior of the device, and then try to find the units that are specified here in this diagram. So in an IoT device, you need to have these like main units. Most of the time, I mean, all the time, we have the power unit, the communication unit, storage and processing unit, sensing unit, right? So these units must be labeled in the image that you have chosen, right? So I mean, basically sensing unit, processing unit, storage unit, communication unit, power unit, you need to mention. The localization, actuation, mobility, those applications might not be available in every IoT device. I just want you to identify only the sensing part, sensing unit, processing unit, storage unit, communication unit, and power units. So these units, I want you to label in the image and do that for 3 IoT products. If we can do more than that, it is welcome. So you can label them and you can submit the assignment. So this is the first assignment I have given. So it is, I think, easy task. So in there, you just need to label the items, components inside an IoT device. So I just want you to understand the components of the general components of uh, an IoT device. Another thing I want to mention is that there are practices that we need to follow when we are collecting information for an IoT system, right? So once we have an IoT system, we need to obtain data from the sensors as frequently as possible. So once we have devices connected to our network, we need to give them unique IDs and associate them with the certain local server. We need to connect it to a certain local server through a communication link that we have specified. And then we have the IoT sensors collecting data at certain frequency, right? And that data must be collected and stored inside the microcontroller with a certain timestamp, and then it must be transmitted from that microcontroller to the local server. So the timestamp must be mentioned in the collected data. And then readings must be collected every fixed time interval, and the frequency of collecting the data must be decided beforehand. And we need to gather the measurements from all the sensors, and we need to increase the number and the types of sensors. That means that we need to take all the measurements as possible from each sensor. And the second thing is that the different types of sensors must be used. That means that we need to increase the number of device sensors. We need to increase the type of sensors that we are using. So the reason for this kind of a practice is to ensure that we have data, a lot of data regarding the scenario, a lot of different data regarding the scenario. So once we have different data, it is easy for us to understand the situation, actual situation of the IoT network. And then best practices for security. So we have to define policies that should be followed in order to maintain the security of the data. We need to provide authentication to the devices. We need to give them certain unique IDs that allow them to have a security once connecting to the network, right? Then we can easily spot the unauthorized users and once we check their IDs, they will be known as unauthorized access devices. Next, so as I said before, we need to consider about the frequency of the data that have been sent from the sensor level to the local server. So it should be decided by considering also the energy consumption, the network bandwidth, and the cost of the data transmission. So that means that we can increase the frequency to a level we want. However, we might need to sacrifice the energy consumption. That means if we have a high frequency of data collection, then the energy consumption will also be high. If we have higher amounts of data to be sent at a certain time instant, then we have a higher bandwidth requirement. So we need to have higher data rates per second, right? And then if we want to very frequently collect data, our cost of the data transmission will increase. Therefore, although the frequency is a very highly important parameter in collecting data in the IoT networks, we need to consider the energy consumption, network bandwidth, and other parameters when we are deciding the frequency of the data collection. Next, we also have data visualization to optimize the system performance. So we need to understand the actual situation of the sensor level by visualizing the data that we have collected, right? So with the time, we can plot the output of the remote environment. So it could be the temperature, it could be the humidity, it could be the moisture in the soil, and so on. So we can plot the parameter against the time or over a long period of time, and using that we can observe whether there are any patterns that is recognized in that remote area. So the data must be collected over a long time in order for us to make some decisions and predictions. Right? So basically, those are the things that I wanted to discuss in today's class. Right? Apart from that, I will give this activity later. Uh, so for the IoT project, I will ask you to first implement a very small project which is using NFC chips and making measurements. Developing a system that can update data in a database or like a Google Sheet based on the information that we communicate to the NFC chip, right? So, for example, we can develop a attendance monitoring system or a object monitoring system using NFC sensors. So once we keep our object near the NFC tag will connect the data from the device that is received from the device to the cloud website, cloud platform, or the Google Sheet, something that can store information in the cloud. And then we will proceed with other small projects where we will learn about the coding of the microcontrollers and so on. And then also we can check the existing IoT platforms and tools that are available and popular these days, right? So those are the activities uh, that I have in store for you. So since you are lateral entry students, I don't know whether you can work as teams, right? So if you cannot work as teams, then I would like to ask you to do these, activities in an individual, uh, as an individual assignment, and then you can get the, output without, working with other, I mean, with another member, because then sometimes you can get a delay of maybe working with the other team member. So instead of that, we can do some individual projects and then we can get the outputs. So in for this course, as I mentioned before, I'm only doing like mini projects where you will only like do a very small task using a microcontroller and using a set of sensors. At the moment in the lab, we don't have microcontrollers in spare for the students. So for the students needs to actually buy the hardware and do the software implementation in the hardware. So yes, the students will have to buy the hardware. However, like in this module, I'm going to like incorporate hardware which are like less in price. So, for example, I want to incorporate NFC, as I said before, NFC chips, which are, as I understand, are the cheapest, are one of the cheapest sensors that you can find in the market. And then we can code them. I mean, we can design or we can use those chips using our phones as well, right? So anyway, I want you to do an activity regarding that. You will also learn that you can just use your smartphone to connect to the sensor and make changes in the sensor's code. And then by changing the code in the sensor, we can do different tasks using the sensor and using just our phone. So therefore we don't need like a very a large amount of hardware or expensive hardware for this module. However, I will anyway choose the I will anyway choose the lowest price modules, right? So I think since this is a IoT module, it's very necessary that we learn how to like program microcontrollers. So because of that, I think we might have to buy them and learn using that. So if you can, just ask and share the equipments that others have in spare, or if they are willing to share with you, I think that is okay. You can just share and get the hardware and do the project, and then you just need to, I mean, just submit the output, and then you can return back the items you got. You might not need to buy all the things. You can use whatever you have, and from that you can implement. So yeah, you can work as teams if it is possible for you to work together. So some people might not be able to work in teams because they are in different locations. However, if it is convenient for you and if you are willing to work together, then for me it is okay that you work as a team and then you submit one. It has a one output. So that is the kind of the update regarding the assignments of the IoT project. And then, so as for the lectures, right, I want you to I will talk about some questions in the upcoming class. So regarding the second lecture, right? So sorry, regarding the actually the fundamentals of IoT. So regarding whatever the content that I have covered in this class, do you have questions? Okay, so is it okay if I conclude the class now, or do you want me to do some more content related to the IoT? Because I do have some questions that I want to discuss with you, but since I think the uh, time is um, like past 1.5 hours of the lecture, I feel that I will discuss the questions in the next class, where you will have a fresh idea or a fresh thinking, and you will be able to like answer and do the questions in a much better way. However, so okay, so the Tuesday evening from 1 to 2, is it like that? Or at what time is it mentioned in the Google Calendar? 7 to 9. Okay. Really, I will just inform that to the administration. I will get some information from the administration, and I will get back to, I will ask the administration to inform you the exact time that this module will be held. Okay, so for the regular students, only 2 hours will be there for 1 week. So if we are having I think that therefore I think only one day should be allocated for this module. So either Saturday or Tuesday. So if it is Tuesday 7 to 9, is it okay for you or not? So what do you prefer, Saturday or Tuesday? Saturday is okay. Is it okay for everybody? I think just can you let me know? Okay, so Saturday is okay for you. So therefore, I think we will proceed with Saturday. I will inform the administration that we can have only on Saturdays, and then we don't need the Tuesday lecture. So I will ask them to, like maybe remove the Tuesday slot, and just have this Saturday slot. So regarding the question about the routers being gateways, as one person asked before, I think IoT networks, like in IoT networks, since the complexity of the protocol that is used from the at the sensor level is kind of lesser than in other networks, where we have complex protocols to send data from different connected devices. In IoT networks, we have less complex protocols to connect to the internet, right? To connect to the local server and then to the cloud. So in that case, even the router can connect or inform about the protocol at the protocol that is working from the sensor to the access point, and inform that protocol uh, to the uh, to the internet, right? Uh, to the different network that is connecting to the router, right? So because of that, at due to the simplicity of the IoT network, at certain applications, we can call the router as a gateway, but not all the time. So because of that, we cannot say that the router is a gateway all the time, because the gateway is a like a device that can detect different network protocols and um, connect the networks in a suitable manner, such that the communication can happen smoothly between the different network protocols. However, since the IoT networks are already defined to move from one different protocol to another different protocol, then the router's task is very simple, right? It is only connecting the um, one network to another network. So the networks that are connecting are already known beforehand. So because of that, in IoT platforms, we can consider router as also as a gateway. But this is not the case for all networks, where the gateway needs to be more intelligent than a router to make decisions to connect different protocols, such that the communication from one end can be done through different different network components to the other end of the network, right? So that is all I wanted to explain. And so thank you for your attendance. And if you have any more questions, I will also answer them. Also, I have a WhatsApp group that I have created for the IoT regular students. Do you want to, join to that WhatsApp group, or is it okay if I create a different WhatsApp group for you? I think I can quickly communicate with you using that WhatsApp group. Then I think any concerns that you have, you can resolve uh, beforehand or immediately using that WhatsApp. So because of that, do you want me to create like a WhatsApp group, and are you okay with me like sharing that? Or uh, if you prefer that, you can contact or communicate using that WhatsApp group also, and get your questions resolved there. So I have already uploaded the link to the WhatsApp group in the LMS. You can connect to the regular students, the group chat, and you can ask questions that you have regarding the course. So I think it would be a convenient way for you to get any questions regarding this module resolved very easily and quickly. So I suggest you to join the group. So that's all from me for today. I hope you had a good class. So thank you for attending, and I will end the class now. Okay. So some of you have another lecture from 6:15 to 8:15 on Saturdays. So regarding that, I think you need to email to the administration and mention to them about this collision, and then I think they will resolve the issue, right? So I think it is difficult for me to get the details about the other lectures currently. Therefore, you need to directly send the email to the administration. You can also CC me in the email, okay? Put me also in the email, and then I mention this collision, right? Thank you so much. If you have any questions related to this course, please put in the WhatsApp, and then I will answer them. And also you can discuss during the next class. So thank you for attending, and have a nice night. Right. Good night.